Good evening, everyone. We are delighted to welcome you to the 14th season of RoboBots. For those who don't know me, my name is Teresa Simons, and I am honored to serve as the Executive Director of the Alliance for Working Together Foundation, also known as AWT. Our history runs deep and wide, with the roots laid down back in 2002. Thanks to Roger Sustar's vision, we brought together the community's manufacturers to tackle common challenges, primarily the need for skilled workers. Since then, AWT has grown into a powerful network of over 500 manufacturers, community, and educational partners, united in promoting rewarding careers in manufacturing. In Northeast Ohio, we are uniquely positioned among more than 5,000 manufacturing companies. These organizations offer not just jobs, but fulfilling careers in clean, safe, and high-tech environments. If you're excited about being a part of something bigger, creating, innovating, and problem-solving, then manufacturing is where your passion will find its home. We'd like to give a round of applause to our educators and advisors. Your guidance and dedication make it possible for these students to shine. Let's also extend our heartfelt thanks to our manufacturing partners. You provide the hands-on experience that is invaluable for these students. Your commitment to fostering the next generation of innovators enriches not only the students, but our entire community. Thank you. AWT JuniorBots is all about lighting that spark. Teams will partner with manufacturing companies from October through April, and together you will build a 3-pound robot from a kit. To make your journey smoother, we've prepared a drive folder with all the necessary materials. These folders will be shared with you post-kickoff. If you don't receive it, please let us know. This is what it all builds up to. Teams will compete in 3-minute head-to-head matches. This competition is double elimination format, and the excitement on the day of the competition will be palpable. But let's not forget, safety first and sportsmanship always. To keep everyone in the loop, we will post brackets on the RoboBots website, so mark your calendars for the last Saturday in April and join us at Lakeland Community College for a day of high-octane innovation and competition.
Hi, I'm Brandon Keeper. I'm a coach for the Mentor Community Team for JuniorBots. It's an exciting time of the year. I get excited and the kids get excited because of the JuniorBots opportunity. I'm a big advocate of what AWT does. It really builds excitement and lets the students learn about manufacturing and STEM initiatives. I'm here today to talk a little bit about the design approach and philosophy that I take when doing JuniorBots with the students. The first thing I do is I sit down with them and I go through and we kind of talk about, the different strategies there is in robot combat. So, it's kind of, I always explain it, and you'll hear this a lot, it's a rock, paper, scissors strategy, right? You can have a control bot, you could go horizontal, you could go vertical. So it's really about what the kids want to do, right? Because it's important that they drive what they want to do, and that way they get excited about it. One of the ways to get them to decide what approach to go with is I'm a big advocate of watching things from the past, so watching JuniorBots and the RoboBots from the past years. Norwalk Havoc is a big one, BattleBots on TV. So all those, they can get an idea of what the different robots are about and what they would like, and then from there, we go into the design process once we kind of choose a general option. Once we decide a design option we want to move forward with, and then we have a bunch of design decisions. And for JuniorBots, I try to keep it simplified and break it down to just the base mechanical principles. So once we get past the type of robot, whether we decide it's a wedge, a vertical spinner, horizontal spinner. And by the way, for those that are just beginning, I would somewhat pursue a wedge bot because it's the simplest. Now, if you have other experience, engineering background, you could go for an active weapon, but wedge bots are the easiest to implement. Once you get there, you kind of decide, wheels. Do you want to go 4-wheel drive, 2-wheel drive? Protected or exposed wheels, there's not a right answer or wrong answer to any one of those. It's different philosophies around and advantages, disadvantages between those. Once you go with the wheels, drive system, you're going to size the motors for the drives. It's a balance between speed and torque. One thing you got to keep in mind, especially for junior bots, it's a smaller cage. A lot of kids think, the faster the robot goes, the better. But you build a robot that goes 20 miles per hour in an 8-foot cage, there's not much reaction time. So I would generally tend towards, 5 miles per hour, 8 miles per hour is about the speed you want within that JuniorBots cage. Once you decide that, motor selection, brushed versus brushless, there's advantages, disadvantages to both. Brushed is a little more robust. There's more components out there for brushed. Brushed motors have a lower startup torque, so if you're planning on being a control bot and pushing, you might want to go brushed. However, brushless motors have a higher energy, power density, so you're going to ultimately be more powerful with a brushless setup. There are fewer components tailor-made for that, but they're starting to come on scene a lot more, even for the beetle weight class, the 3-pound weight class. Once you get by the drive system, then you're looking at your weapon system. So if you decided to run a weapon, lots of decisions there. First thing is, how much weapon energy do you want? Typically, general rule of thumb is about 150 joules per pound. So for this weight class JuniorBots, that'd put you in the 450, 500 joules. If you're running that, you're in good shape from your energy standpoint. And when I talk about energy, I like to relate it to things kids would know. So 100 mile per hour fastball is about 150 joules. A major league swing is about 500 joules. So these bots, and that's another thing for safety, you're stressing, these bots are putting out the same amount of energy as a major league person could swing a bat. So definitely dangerous. Safety comes first when you're starting to get into these weapons. All right, once you decide the energy that you want your weapon to be at, a lot of kids, again, the more energy the better. That's not always the case. You're going to put your energy back into you. Unfortunately, last year we found out the hard way. We broke our bot when we put all our energy back into ourselves. And we'll go into it later, but I didn't have the one spare part that I needed to continue on the competition. But once you determine the weapon energy, there's another thing called bite, right? It's how much the weapon can engage into the other opponent as efficiently as possible. So the faster you spin the weapon, the more energy you get. You get the square of the speed of the weapon. The energy goes up by the square of it. But, however, you get less bite. And what that means is you transfer less of the energy you build up, kinetic energy in your weapon, and transfer it to your opponent. So there's things you can do. You can go with a single tooth asymmetric blade. You can slow down RPM, or you can just go heavier, moment of inertia, bigger weapon, and slow it down to try to keep that same amount of energy. And then once you decide that, it's about weapon motor sizing. So there's spin up, speed time, and then the ultimate RPM you want to get to. So that basically helps you size the motor you need for combat. And then after that, it goes into the electrical system. That electrical system is going to be dictated a lot by what drive motors you selected and what weapon motors you selected. So there's number of cell counts. 3S would be your typical 12 volt. 4S goes to like 14.4. And then 5 and 6S. So for this competition, I believe they max out. The limit is 24 volts, so you don't want to go above that. And then in addition, there's the capacity of the battery as well, the milliamp hours. And there's, using calculators, you can understand how much capacity you're going to need in your batteries to last a 90-second match. Once we get some of those design decisions out of the way, then we look at our design tools. And again, I try to explain it on a very high level to the students, especially at the junior bot middle school level. We talk about gear ratios, low gear versus high gearing. Again, and it's going to be a speed to a torque preference. We talk about circuits, so very simple things, parallel and series wiring, what that does for the batteries. We talk about the energy calculations. We got into that for the weapon. And then we'll talk generally about material properties. What type of materials do you want to use where? For the frame, could be a different material than the armor you use. The weapon blade or system would be also a different material. We talk about things like strength, hardness, toughness, and where those need to be on various spots of the robot. One thing I emphasize a lot is to utilize calculators, especially for new teams. There's a lot of design calculators out there. You can look on the website I've got on this spreadsheet. And that tells you, there's weapon spin-up times and calculators, energy calculators for those, and it makes it simpler. And a lot of graphical things. So it's nice to see the kids plug in the numbers. They can see and play around with what changes for them. Another thing I've done in the past is I've reached out to the robot community, and these are guys that, even the BattleBot guys, the guys that go to Norwalk Havoc and compete for money, they're very friendly. They'll get back to you a lot of times. You'll send them an email, and if you have questions about how they do things, they have a ton of information out there on how they do things and what they've experienced and learned from the past. We also keep a BOM worksheet, a bill of material worksheet. That's all the components and the weight of the components. That's one thing where we start sizing and weighting up and making sure we don't go overweight and making sure we're not that far underweight. You really want to be right up until the weight limit to give yourself the full advantage. I use Excel for that. The SWOT analysis sheet is also a good thing. It's really just a basic really simplified system design FMEA, where we're just talking about the strengths and the weaknesses of the different bots. And we use that a lot on the upfront side of our decision of what type of bot do we want to run and design for. And then there's CAD, a lot of different CAD packages out there. Not a lot of the students don't run that. I'm able to do the CAD myself with their input. So once we get and make the design decisions, we move on to the manufacturing options. A ton of options out there. I like the newer manufacturing out there, 3D printing, additive manufacturing. So we definitely, I'd like to introduce the students to that. We definitely have 3D printed parts. The nice thing with the 3-pound beetle weight, you can have a lot of 3D printed parts on the robot. There are various materials. There's FDM out there. Some people have FDM printers at home. If you don't have one at home, there's a lot of maker spaces out there, so you could utilize those. There's SLS or MJF, like Multi-Jet Fusion, HP. Again, that's one of my favorites. You can go to sites like Xyometry, Rapid Prototypes, and it's really not that costly to do. So if you don't have one, you can't make it to a makerspace, it's not that costly to have a few parts made via a vendor or service bureau. Another thing we like to use is laser or water jet for sheet material. And this is when you want to cut 2D parts. It's a great manufacturing process. You can cut 2D parts and bend them into 3D, or there's a lot of things like weapons that just stay 2D, and you can make them out of the materials that you need for the weapon system. Another place I'll throw out there is Send Cut Send. So they do very cheap laser cutting or water jetting. So it's a nice place to go to if you don't have access again to something that can do those types of materials or that type of equipment. There are local maker spaces. ThinkBox is great. Another one is Hive at Lakeland. So those are great places to go. They don't have some of the same capability of like a Send Cut Send for some materials, but some materials they do, and it's perfect. Prefabricated components, so these are purchased items, right? So there's lots of places I like to go for that. McMaster-Carr is a great one for bolts, fasteners, all miscellaneous stuff. You can get it next day. Very good. Servo City, more around robotics, motion control, so gears, pulleys, belts, bearing holders. FingerTech Robotics, same thing. FingerTech Robotics, they have more weapon system blades you can get. So off the shelf, the FingerTech beater bar is a popular one. A lot of people run it. They also have wheels. So we talked about the decision on the wheels, whether you go foam or rubber. FingerTech's got the foam wheels. BaneBots is another good one for gearboxes. Their gearboxes are probably a little big for JuniorBots. A lot of high school RoboBots use a lot of BaneBot gears. Getting the wire connections. My favorite for the JuniorBot is an XT30. Very robust, carries plenty of amps. It's rated to 30 amps, but it'll carry 60 up to 90 amps. Short-term use. There's the bullet connectors. There's soldering. I try to minimize soldering even myself. I'm not great at soldering, so I try to minimize it. And then one of the things that's helped out a lot for our team is these Wago connectors. You snap them open, lever connectors, and you push it in the wire and you close it. I got them for prototyping, but I found out they were robust enough for combat. We've never had any of them pop out or anything. And you can quickly change over and replace parts with these Wago connectors. And then I didn't want to leave out traditional manufacturing. So still a lot of items could be either milled, you got to use drills, Allen wrenches, screwdrivers, soldering iron, saws, sanders. So for the JuniorBots, there are some definitely milling. We get into CNC routers, and you can find those again at makerspaces. So if you want some 2.5D work in material, CNC router is a great way to go. And then last but not least, I wanted to talk about the day of the competition. First and foremost, kind of the safety around it. So the PPE, really focus, making sure you have the safety glasses, making sure you have your cut-resistant gloves, making sure you have the weapon restraints for your bot, the box. One thing, I forget to mention, a lot of these are kids that aren't accustomed to manufacturing locations or spaces. So last year, one of the students showed up in sandals, and I'm like, ooh, that's an open-toed shoe. It didn't cross my mind to tell them about it, but that's one thing, we learned. So just try to remember, what you would wear maybe in a manufacturing floor. Try to make sure that the students will be wearing those similar items. Tools, so you definitely want to bring all the tools. So every tool that you can bring that you use to assemble your bot and put it together, try to bring that. And in addition, you're going to be making some triage changes, right? You're going to have your bot obliterated, and you're going to have to try to repair it in time for the next fight in some cases. So tape, hot melt glue, Dremel, you might have to cut things, scissors. So anything that could be used, quick emergency repairs, anything you can think of. And you might not, as a first team, think of everything, but the nice thing about it, again, this community, very friendly. Other teams, we've gone to the past, we've used other teams' tools, and they've used our tools. So it's a little bit of a community, and it's great to see, that even the day of the competition, when they are your competition in the box, but they're very friendly outside of the box and lend a helping hand. And then spare parts, everything you think that can break could break, so try to bring all those spare parts. Unfortunately, I touched on it earlier. We had a situation last year as I had a plethora of spare parts, but the one thing that broke, our main carbon fiber shaft broke, and I didn't have a spare, so we weren't able to continue on with the competition. Definitely will not repeat that this year. And then as far as batteries and chargers, have extra batteries. So not only batteries for your bot, but remember the batteries for your transmitter. Have extra batteries available. Have the chargers, and if possible, bring extension cords. But again, a lot of teams bring extension cords, and usually there's a little battery charging station that's made during the day of the competition.
Thank you all for being here today. Let's make this RoboBot season the best ever.